Okay, so our third algorithm of the day is merge sort. This is a slightly more complex algorithm to implement and to actually, I'm afraid, understand, but it's a lot more efficient than the other algorithms we've spoken about. So merge sort is an example of what we call the divide and conquer algorithm, and you'll come across more divide and conquer algorithms in your computing science career. The idea here is we divide the array into different parts, and we then sort each subarray, and then we merge them back together into a larger sorted array. Divide and conquer algorithms are always like this. The whole idea is that you divide the data in some way, and then do it in different parts, and then somehow merge back in. That's kind of what divide and conquer algorithm is by definition. Obviously, we'll divide and sort subarrays using the merge sort approach as well, if the subarray has more than one element. Okay. So the goal is to reduce the array to one element and then merge them in the correct order. Okay, so here's an example, because I know that can be quite difficult to understand. So I've deliberately chosen an odd number here of elements for us to work on, because it shows you that the algorithm doesn't have to be symmetrical. It can work in an odd number of ways. So the first thing we do is we divide our data up into not quite half, because it's 4 and 3, that's fine. So we end up with 38, 27, 4, 43 and 3 in one half, 9, 82, 82, 10 in the other. We then take both of those separate parts and then divide them again. And that gives us 4 separate arrays at that point, one containing 38 and 27, one containing 43 and 3, one containing 9 and 82, and one just containing 10. And then we end up with just 9 separate, completely separate algorithms. At this point, this is where the sorting actually starts to happen. So all we've really done up until now is divide it up into separate elements. So the first thing we do is think, okay, the first array that I broke up was 27 and 38, so I want to remerge that such that it's now in the correct order. So I'll do that, get 27 and 38. The second one I broke up was a 43 and a 3. Again, remerge that so it's in the correct order. So that gives you 3 and 43. 9 and 82 is already in the correct order, so that's fine, and then 10 by itself, so that's okay. So now we remerge again. So 27 and 38 and 3 and 43 get merged together. And the way we actually do that is out of the 4, we look for the lowest element, and it's 3. And then we look and see what's the second, third, and fourth, so that's how you carry on through. You also do the same with the second half, so 9, 82 and 10 get merged. And then we put the whole thing together and end up with the algorithm completely sorted. So that's how merge sort works. Merge sort begins by dividing the array into 2 parts, and it does that until the array is completely separated into arrays of 1 element each. That's a logarithmic based operation, base 2, and therefore it actually computes in O log n time, because you're separating each time by base 2, so it's complexity is big O log to base 2n. In general, by the way, whenever we say log in computing terms, it's log to the base 2. So it's something that's worth remembering because it sounds like confuses students sometimes. If it's not log to the base 2, I'll always tell you. Okay. The merging the divided array runs in big O(n) time for each separation. So putting both operations together, what we actually get is a sorting algorithm that runs in big O(n) log n, which is a lot faster than n squared. So this is much faster than both selection sort and insertion sort. Okay. So what I want you to do now is again take your playing cards and actually try and work through this algorithm with playing cards. I'll tell you now the first bit's really easy when you separate it down, that's quite easy to do in person. The merging back together can be a bit difficult, and sometimes you think, how is this actually operating? And there are different ways of doing the merge. So what I'm going to do is give you some code which Chi actually wrote for merge sort, and you can see the way that he's done it. Analyse that code. Okay, well that brings us to the end of our third sorting algorithm. Our fourth will be quicksort, and I'll be with you with that in a few minutes.